Sample of 250 grams of kryptonite 713 decays to a size of 200 grams over 19 days. So we've got this radioactive substance, and we'd like to find the half-life of this substance, which just happens to be fictional. So we know that half-life is the amount of time it takes to cut in half. We don't actually know that yet because we know how long it takes to get from 250 grams to 200 grams. So we're going to start with our model, y equals a times, e to the bx, or you can use t because we're talking about time. And we know that our initial amount is 250. So 250 e to the bx is what we know as for our formula. But we also know that after 19 days, we end up with 200 grams. So if I plug that in, I get 200 for y. And then I've got my 250 e to the b times x, which we'll say is 19 days. So we're measuring in days here. And now I can solve for b. Well, I can divide both sides by 250. And when I do that, this here is 0.8 equals e to the 19b. You can take the natural log of both sides, and we get 19 times b on the right side, and then divide by 19. So the natural log of 0.8 over 19, that's my b. So my model, I have y equals 250 e to the b, which is the natural log of 0.8 over 19 times x. Now that I have my model, in order to find the half-life, I know that the half-life is just the amount of time it takes to cut the mass in half. Well, from 250 to cut that in half, I would end up with 125. So I have 125 equals 250 e to the natural log of 0.8 over 19 times x. And now I can solve for x, and that will be the half-life. Divide both sides by 250, and we get 1/2 equals e to the natural log of 0.08 over 19 times x. Then I can take the natural log of both sides, and I have the natural log of 1/2 equals, and then here it just cancels the base out. So now I've got that whole exponent. Natural log of 0.08 over 19 times x. So now solving for x, I multiply both sides by 19 and divide by this natural log of that's not 0.8. I totally messed that up right there, didn't I? Totally messed that up. I'm sure you caught that. Over the natural log of 0.8. Glad I caught that mistake. All right. So now that's my x. That should be the half-life. Let's go ahead and plug that into our calculator and go ahead and do that over here. So we've got 19 natural log of 1/2 over the natural log of 0.8. Make sure I type that in correctly this time. All right, go ahead and hit enter, and I get 59.0194. So 59.0194. That's x. Now this, we're measuring x in days because up here we had 19 days, and that's what we plugged in for x. So we're measuring x in days. So the half-life of this fictional substance is a little bit more than 59 days.